market structures, for competition, which is the first one we're going to talk about, and profit maximization. So I kind of had started just briefly on the that discussion with the four structures, perfect competition in one extreme, at the other extreme is the monopolist. And then there's a couple in between. Each of them for the next few chapters we're going to discuss. There's a little summary sheet, summary slide in here that we'll get to in a second. What market structure is defined as is that selling environment. The selling environment in which the firm produces and sells its product. That's what the structure of a market means. Whether it be retail apparel, which has its own environment. We talked about how that's more of a monopolistic competitor, or a farmer growing strawberries, which is more in line with perfect competitors, because it meets certain characteristics. The three characteristics generally, when you think of the selling environment, is the number of firms in the market, not the like one or hundreds of thousands of them. The ease of entry and exit of firms. What does that mean? It means that, well, how easy is it for me to become a strawberry farmer? Probably not difficult. I mean, you gotta have some land. So the property cost would be there. You have to buy the land. Obviously the raw materials, the machinery, maybe maybe a lot of manual labor with it, but it's not too difficult to enter that market. Not a lot of restrictions. However, to enter the airline industry, compete with United and Southwest Airlines, all the major airlines, it's a little more difficult. The entry is kind of restricted. The restriction actually is the financial restriction there, the capital. It's difficult to get into that market financially. Sometimes there's other kinds of markets like the post office. It's difficult to get into that industry because they're regulated by the government. And so you can't compete with them in first class postage stamps because it is restricted to just the U.S. Postal Service. Exit, that means just leaving. How easy is it to leave? Well, if you're a strawberry farmer and you're not making any money, you just pretty much shut it down, sell the land, you're done. Exiting, the airline industry might be a little more difficult. It's going to be more costly. Exit, you can exit pretty easily in any industry. You just don't make any money, you just leave. But it's going to be more costly. The degree of product differentiation. What's the distinctions between it? If the products are similar or the same, then that's more in line with perfect competition and monopolist, well, not monopolistic competition, but more in line with perfect competitors, which is what we're going to talk about this chapter. As you get further and further away from perfect competition, the product differentiation increases. There's uniqueness, there's differences. And that's why retailers have different types of apparel to try to attract different buyers. There are four forms of competition. They compete through price alone or through the advertising and product differentiation modes. When we get into the chapter on monopolistic competition, there's a section of the notes that really just talks mainly about advertising. And you're thinking when we get into it, you go, well, that sounds like marketing class. And it is a lot about marketing and promotion, but there's economics to it. There's a reason why we kind of use economics with the idea of advertising. But here are the four market structures I had given you that day before the break, and the characteristics, essentially the first three, the ones that are important: the number of firms, the type of product, and ease of entry. perfect competition, monopolistic competition, oligopoly, and monopoly. And the characteristics there are summarized. What we're going to deal with is this one right here for this chapter. Is the perfect competitor. There are many firms. They sell identical products, the same or similar. The ease of entry is high. That means it's very easy to get in, very easy to exit. Okay. Examples are wheat, apples. Those are agricultural things, farming. And that's usually the classic example, farming of anything. It's a perfect competitor. At the other end, which is the next chapter we're going to get into, I'll probably put the notes up before Wednesday, monopolies, the other extreme. You can see the three characteristics. There's one company. They're unique products typically, and the entry is blocked somehow, regulated by the government. There is no such thing as a monopolist that isn't regulated. It just isn't, because there are laws on the books to prevent companies from monopolizing markets. That's called the Sherman Antitrust Act and the Clayton Act. There's a couple of major legislation. The examples I gave you: first class delivery of mail, natural gas companies, electric companies, anything that's regulated as far as utilities is considered a monopoly. Because again, you can't choose your electric company. You have to use what's there. And then the two in between, some of the things, characteristics of those. So let's look at perfect competition. We're going to look at that throughout these set of notes. Perfect competition is considered a price taker. Well, a price taker is characterized by they take that price that the market tells them it's going to be. Some other attributes here: many firms, so no one has the ability to affect the market. You have many farmers, so no one farmer can affect it. They're identical products. Now, I did mention either standardized or undifferentiated. That means the same thing, just another kind of technical way to say it. Got a standardized product, standard tomatoes or strawberries. They're not different. I know there are different kinds of tomatoes. I know there are different kinds of oranges. I get that. But for the most part, it's citrus. For the most part, it's a tomato. Okay. The products are identical, generic in nature. Easy entry, again, characteristics that it's all in the other. The demand curve, this is something different. The demand curve is perceived by each firm to be horizontal. That's interesting. The demand curve, normally downward sloping like that. Well, for the perfect competitor, it's horizontal. It's going to be like that for each individual firm. Buyers, which are the consumers, and sellers, which are the firms, the companies, have perfect information. We talked about that back in the chapter on law of demand. They had the same information, perfect information, both parties to the transaction. The firm is a price taker in that it takes the market determined price as the price it will receive for its output, for its product, whatever it's making. The next slide is a picture of that, like this, where here's on the left is the market. Okay, so here's the market, and this is bushels of, I don't even know, bushels of wheat maybe. Bushels of wheat. The market, because of the number of farmers in the market, that's the supply, and the number of buyers in the market, that's consumers, whomever may purchase the wheat, manufacturers to make cereal and that kind of thing. The interaction of that has determined that the market price is $1 for a bushel of wheat. And in that market, there are 20 billion bushels of wheat being sold in equilibrium. Well, that $1 price is what's determined, and so the farmer has to take that price of $1. Has to sell his product at $1. You can't sell it for $1.25. You can't sell it for $1.50 because he might think he could get it for it. He can't sell it for $2, $3, $4, and why he wouldn't want to sell it for less than $1 to make any money. But if he tries to sell it for $2, then the customer, the buyer, is going to go, well, the going rate is $1 in the market. Everybody's selling their bushels of wheat for $1. Yours is $2. It's the same thing. There's no difference. Remember I said they're identical products, they're generic. So why are you wanting two? Just being greedy, but he's not going to be able to do that. So he has to go back down to the $1, and that's why he has to take that market-determined price. Again, he wouldn't want to sell it for less than $1, unless he wanted to try to undercut the rest and try to sell more, but that would probably force others to go down too. So we're going to look at the revenue of a competitive firm. There's going to be a little table here, I think, coming up. And the competitive firm has the same type of revenue potential as any other business. One way to calculate revenue is to multiply the price times the quantity. When you're looking at a table, we've had throughout the semester the price and quantity listed in a table. And so if you multiply the two together, you get total revenue. That's what this is. It's all total revenue is. We're bringing revenue into this discussion now. In the last chapter, before the break, maybe you don't remember it, we talked about cost. We had all the cost numbers, total cost, fixed cost, variable cost, average fixed cost, average variable cost, all that. Now we're bringing revenue in, okay? And we're going to put the two together. Graphically, total revenue increases at a constant rate as each unit sold sells for a constant price. Remember, $1, or whatever price I want to use. So I have a table. Let's see. I think I want to use the table here for the perfect competitor is a dairy farmer. That's my example. Like a strawberry farmer, the dairy farmer is going to sell gallons of milk. And the dairy farmer is in competition with many other dairy farmers. I'll put the quantity first. It really doesn't matter, but I just think it looks better when you put the quantity of output. What are you selling? Gallons of milk. Go ahead and start with 0. Sometimes I don't put that, but I think later on we'll see it. You're going to need it for marginal amounts. But we're going to sell the gallons of milk at a price that is already determined by the market. It's like that one with wheat was $1. That was the market determined price. We're going to use a different price for this example. But I'm going to put the price at $6 a gallon. Now that's a lot, I know that, but just go with it, all right? I kind of pilfered this from another book, and I always liked this example. But the gallon of milk costs $6. Well, even if we don't make anything, we still have to list it as $6. But if we sell 1 gallon, we still sell it at $6. If we sell 2 gallons, we still sell it at $6. If we sell 3 gallons, we still sell it at $6, and so on. So you list the data here. Let's see how far I want to do it. I want to go to 7. Total revenue is the next column. In order to calculate it, I had it on the previous slide. We multiply the two together. This will be 0. P times Q. This will be 6, 12, 18, 24, 30, 36, and 42. I want to leave a little bit of space in this next little section. If you want to put the title, the heading, you can. I want to put total cost in here, so you want to leave a little space there. I'm going to bring it back in a minute, but not a minute, but a few minutes. You want to just kind of leave a little column for it. But before we get into the total cost thing, let's go ahead and start talking about what average revenue is. Do a little bit of calculations. Not only is the firm making total revenue, bringing in this amount of money. If we sell 7 gallons, we're making $42 in revenue. We don't know how much profits that is yet. We're just bringing in that kind of money. Can you put your backpack on the floor? Along with your cell phone? Thank you. I'm not sure. No, I'm just not sure. Are you looking at your cell phone? No? So I want to do average revenue. Average revenue is the next column, and average revenue is total revenue divided by quantity. That's the formula there. So let's go ahead and calculate that. Total revenue, obviously 0 divided by 6 is 0. Uh, 6 divided by 1, the quantity is 6. 12 divided by 2, quantity is 6. 18 divided by 3 is 6. So it's going to be 6 all the way down.
Yeah.
I'm trying to make sure it's lined up because we're going to need it to be fairly neat across the row. But I want to graph this. I'm going to graph it so you can see it, get an idea of what it might look like. The graph will have the quantity on the axis and the horizontal axis, and then the dollars on the vertical axis. And sometimes the way you scale it off might make it look better or worse, and I always kind of forget how I did it the last semester. So we'll have quantity here of gallons of milk. Let's see, 1, 2, 3, 6, 7. Price, 6. It's going to be 6, but let's argue here. 12 over here. 18. Yeah, we're around a room here. 24. But I want to plot the column for the first two, the green. Price and quantity. And we know if we plot that, we're going to have the demand curve. So at 0, price was 6. At 1, the price was 6. At 2, the price was 6. At 3, the price was 6. 4, 6. Same. It's $6. So when you connect the dots, this demand curve for this individual dairy farmer is horizontal. It's in a horizontal demand curve. It's flat. Now I used a lowercase d. There is a significance to that. The small case d indicates one firm or one farmer in the market for selling gallons of milk, dairy. If I use a capital D, that usually denotes the entire market. So $6 is our going rate. So this farmer has to use that price of $6 when selling his gallons of milk. So it's horizontal. So there's the graph of these two columns. Well, let's graph the blue, the total revenue line. The total revenue line, when you graph, and this is where it's going to probably go way up, it increases there, starting out at 0, and then at 1, quantity of 1, it goes to 6. At a quantity of 2, it goes to 12. At a quantity of 3, it goes to 18. 4, 24. And then so on. It's a straight line, but it's increasing here. That's our total revenue line. And again, later I'll bring in the total cost line. We can kind of put that one in. Average revenue, we plot that line, which is total revenue divided by Q. We did the calculation. What is it going to be looking like? If we plot the line, again, we're going to plot it 0, 0, or a quantity 1 to 6, 2 to 6, 3 to 6. It's going to actually be the same as this line. It's going to be all these dots that we've already plotted. So this line here is actually the average revenue line too. This only happens in perfect competition. It equals the price of the good in perfect competition, average revenue. It doesn't happen in any other market. It doesn't happen in monopolies or monopolies competition or oligopolies. Only in perfect competition. How about marginal revenue, which will be the next column we calculate here. Marginal revenue is the formula, the change, that delta sign of total revenue divided by the delta sign of quantity. So I have it listed there. And like with average revenue, marginal revenue equals the price of the good in perfect competition. But it doesn't do it in any of the others. It's not a coincidence. It just doesn't work in the same way. So we calculated. This is where I said I wanted to start off with a 0. If I start off with a 0, it just works better. The change in total revenue here is 6. The change in quantity is 6. So if you kind of come across here, it's in between the two rows. So the change is 6 over 1, which is 6 for the marginal revenue. The change between total revenue 0 to 6. Here the change between total revenue is 0 to 6 to 12. And so the top number is 6, bottom number is 1. 6 over 1. So $6, it's going to calculate to be $6 all the way down. You get 6 over 1 here too. So I'll go ahead and fill it in. I'm filling it in between the rows. So like average revenue, marginal revenue equals the price of the good in perfect competition. So you go back over here. Good question. So you go back over here and plot those points. You're going to get the same. Actually, the plot points will be a little different. I should not say it like this. The points actually are in between because it's between 1 and 2. And 0 and 1, 1 and 2, 2 and 3. So it's actually this point here, this point here, this point, 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 between the quantities. But when you connect the dots, it's still a horizontal line. So it's marginal revenue. So this horizontal line at that price of $6 is the marginal revenue line. It only happens in perfect competition when all three of these are the same. In the other market structures, they're separate lines, they're separate drawings. The goal of a competitive firm is to maximize profit. So now I'm going to bring in this column. We have total revenue. Now I'm going to just throw in the total cost numbers. I'm going to give those numbers to you. But the goal of the firm is to maximize its profits, whether it be a farmer selling dairy or a strawberry farmer, whatever it might be. I'm trying to think of something in agriculture. Let's start to be, well, and it doesn't really matter. It could be a retailer. A retailer, its goal is to maximize its profit. So if you're selling clothes, trying to maximize profit. So any type of competitive firm is to maximize its profits by taking total revenue and subtracting its total cost to come up with profit. The profits, the maximum profits occur at the distance between the revenue and the cost. That's graphically. So I haven't given you the cost numbers. I'm going to go ahead and give them to you. Just imagine that 2 weeks ago I gave you the cost stuff, where you took the test on cost. You had fixed cost, variable cost, and you added them together and you got fixed total cost. And just imagine though, I'm just going to give you the total cost, which is made up of the variable and the fixed. So the total cost of producing dairy, gallons of milk, is it's not 6, it's, the first one is $3, and that's at 0. Then 5, then 8, 12, 17. So that numbers, these numbers I'm just giving you. However, if I really wanted you to, if I really wanted to figure out if you really knew it all, I could give you a massive table that we had last week with cost, or 2 weeks ago when we had cost, which had all the columns for cost, fixed, variable, total. Then I could give you the revenues. I could give you the revenue line and the column for average revenue, marginal revenue, average fixed cost, average variable cost, marginal cost, all that. The table would have probably 15 columns. And you could take those numbers and be able to tell me what profits were. Then we're going to use something else called marginal analysis. So first off, the accountant's going to do this. They're going to take, the accountant's going to look at the profit, or total revenue minus total cost. Well, they're going to do that guy that just counts the beans, the accountant in the company, he's going to say, what's the profit between the revenues and the costs? Here it is. We want to try to maximize that. If you subtract these two, total revenue minus total cost, you're going to get the profits. I'm going to come over here to put the profit number. So 0 minus 3, and it's not a positive number, it's a negative number. It's negative $3. 6 minus 5 is 1. 12, 4, 6, 17, I mean 7, sorry, 7. 7 again, and then 6, and then 4. So I'm just subtracting the total cost from the total revenues. Where are they maximized? In other words, where's the highest number?
7.
Right? 7 and 7. It happened in two instances, 2 times. So the profits are maximized right here. Now, if you bring that back over, all the way over here, they're maximized at somewhere between 4 and 5 units. Okay? 4 and 5 gallons of milk. So if they sell 4.5 gallons, or if they sell 4, or they sell 5, they're maximizing their profits. If they sell 6, they're not maximizing, they're only making $6. If they sell 7, they're maximizing, and they only get 4. So the profits actually go down when you start to sell more. Why? Because the costs are rising. So you're trying to maximize where would be the what really would be the most profitable amount of quantity to produce based on the data that you have. It would be somewhere between 4 and 5 units. Okay. Now again, these are simple numbers, small numbers, easy to calculate and add and all that. Now graphically, this will look a little. Graphically, this is what this is talking about here. I think there's a picture in your book of it. I might even have one in here. I think I do have one of a graph illustrating that graph of the total cost. So if we let's plot the total cost line. Got to do that. Total cost line will be starting out at 0 and 3. So right here, that's 3. Then 1 and 5. I'm just doing quantity and total cost. So right here. 2 and 8. Let's see if this will be 9. So that's got to be about right there. 3 and 12 here. 4 and 17. A little bit further up. 5 and 23. Wow. I really got off there, didn't I? Now it's hard to. It should be over here a little bit, but hard to line it up. Somewhere around here. And you connect those dots, or X's here, and you have the total cost line. Okay. What they're saying with the distance is the gap between, this should be here and there. This is the gap between the cost. This is the gap. Okay. The gap, the difference or distance between the revenues and the cost. So this gap is increasing. There's a point here in this where the gap is larger. And it is largest between 4 and 5 units, although my drawing isn't really neat to show it. But somewhere between 4 and 5 units, this gap is it's at its largest space between. The next picture I think shows it. Yeah, the top one. The one on the top, it's a little bit nicer drawn there. This is not the actual same numbers. It's close, but it's not the same. They're using $4 as the market price. But this is a close one. And so you've got the total cost, and this is the green line, and then the revenue line is a straight line like we have there. And you see the biggest gap is at 6 units, 6 bushels of whatever it is, wheat. So this is a similar drawing, nicer drawing. I think your book might have something like that too. So we've drawn the total cost and the maximum revenue between 4 and 5 units. So we can either figure it out graphically. If we just plotted the points, we could say, okay, here are maximum revenues. It's hard to see here because I didn't do it that nicely. But you could see it on the other one on the slide where, hey, distance between revenues and costs are the largest at 6 units, 6 bushels of wheat. Or we can do it like an accountant would do it on paper. And here it is, between 4 and 5 units. We're maximizing our profits. What the bottom line is, or the bottom picture is the marginal analysis illustration. Maybe I'll come back to that in a second. But I want to kind of talk about it first. I couldn't take that little slide off. So like I said earlier, price is the same as the firm's average revenue and its marginal revenue in a competitive firm environment. If the cost of producing one more unit is less than the revenue it generates, then a firm is available, then the profit is available for the firm that increases production by 1 unit. So the cost is like this here. The cost of producing a unit is less than the revenue, which is this kind of example here. Then a profit is available for the firm to increase its production. So they could increase the number of gallons of milk sold. If they increase it, now they are selling more gallons, getting more revenue, and their costs are increasing too, but their profits are increasing. So by doing it 1 more unit, see how far we can go, but we want to try to maximize it. If it's if the cost of producing 1 more unit is more than the revenue it generates, then increasing production reduces profit. So you can go the other way, and especially on the first row. By the way, I was going to ask you this question earlier. In this first row here, what are fixed costs?
$3.
$3, thanks. I mean, you know that because total costs are 3, at a 0 production, our fixed costs are always 3. Profit is maximized. Now this is the marginal analysis. This is where the economics comes in. The economist is not going to look at the numbers as much like an accountant would. The economist is going to take this and go, okay, let's look at the marginal amounts. The marginal revenue and marginal cost. Now we got marginal revenue up here. Do we have marginal cost? No, I don't have it up there, but you can do it. You can do marginal cost. If I would have thought ahead, I would have left a little space in there. I didn't. Well, let me see if I can fit it in. I want to try to fit marginal cost right here. Marginal cost, if you recall, is the change in total cost divided by the change in quantity. It's the change in total cost divided by the change in quantity. That was something we had before spring break. We took our test on it. So to calculate that, the change in total cost, we have the numbers. Here it is. Here they are. My total cost. And as I change them, as I increase them, I'm going to divide by 1 the units every time. So the first amount would be change between 3 and 5 is 2 over 1, which is $2. The change between 5 and 8 is 3 over 1, which is 3. The change between 8 and 12 is 4 over 1, which is 4. 12 and 17 is 5. 17 and 23 is 6. 23 and 30 is 7. Over 1 is 7. 30 and 38 is 8 over 1, which is 8. That just so happened they went up by 1 each time. I mean, that's just a coincidence. But where is marginal revenue equals marginal cost? Where is it equal? Where are those two numbers equal? Right here. And lo and behold, it's the same. It's the same quantity between 4 and 5 units. That's not a coincidence. That actually is what it's supposed to do. They're equal. Marginal revenue is equal to marginal cost at the same amount, same quantity, that we did it using the accountant method of total revenue minus total cost. So you can do it as an economist, maximizing total revenue, or maximizing total profit, sorry, with using our marginal amounts. if I go ahead and put marginal cost curve on the graph, yeah, I don't know how well it's going to turn out here. It should come out to be between 4 and 5 units. Again, drawing it by hand kind of throws it off here. But we'll go ahead and plot marginal cost. Marginal cost in the column I just added in, right here. We plot that between 0 and 1, the marginal costs were 2. So about right here. Between 1 and 2, marginal costs were 3. Between 2 and 3, marginal costs were 4. Between 3 and 4, marginal costs were 5. Between 4 and 5, the marginal costs were 6, right there, on the line. Between 5 and 6, they were 7. Between 6 and 7, they were 8. So if you connect this line, actually it turns out to be pretty much a straight line. This is your marginal cost line. Marginal cost and marginal revenue. This is marginal cost, this is marginal revenue. They are equal at that point, between 4 and 5 units. If you don't remember anything else today, I don't know, you may remember a few things, but remember that thing I have in bold print. Marginal revenue equals marginal cost. Because guess what? You're going to see it in the next 3 structures. Perfect competition, monopoly, oligopoly, monopolistic competition, all use, it's all the same. You have to have marginal revenue equal marginal cost. That's where you know profits are maximized. So if of anything today, this is the one thing you got to remember. So graphically, you can see what happened. You can see we plotted everything, marginal revenue equal marginal cost, and there we have it. So if I go back to that slide that had 2 pictures, this one. On the bottom, that's what we've shown. Here's your marginal revenue. Here's your marginal cost curve. They intersected right there. And actually, this is off here. This is off. Just the caption is off. It should be, this line, I don't know what happened here. This red line is like it's moved over a little bit. It should be right there. Let's see if I can change that on the slide. This I got out of another book, but it's off a little bit. It should be where the marginal revenue and marginal costs are equal at 6 units. I mean, the quantity was 6 in this example. Ours is between 4 and 5. Ours turned out okay. Between 4 and 5 units, marginal cost equals marginal revenue. A competitive firm will adjust its level of production until the quantity reaches what we call Qmax, where profit is maximized. So oftentimes I use the phrase, the letters Qmax to illustrate. If I don't have any numbers, I'll just say, okay, it's Qmax. That's my quantity maximization amount. And so it's somewhere between 4 and 5 units. If we produce 3 items, we're not maximizing our profits. If we produce 7 items, we're not maximizing our profits. And you probably think, well, gosh, we're producing more. Why would we maximize? Because we got more costs. So just because you're producing more doesn't mean you're making more profits.
That's like the.
Here's a picture I think it's in your book, isn't it? I think I'll go for this one from the book. I think. It has a little, this is bushels of wheat. Maybe it's not. Well, here's, I just added in. This is the marginal revenue line. It's actually doing something I haven't talked about yet. It's got the little block here. I don't want to really discuss that one just yet. Kind of, that second illustration is a little bit ahead. I couldn't take it off, but I think this is what's in the book, right? Total cost, this is your total cost and total revenue. That was kind of one I tried to draw. So let's talk about this little rectangle here. What's the rectangle illustrate? I've changed it here to a different one, but I think I can, well, I could. We could try it. We could try to do it. We could add another column over here. Average total cost. We can try to see if we can graph it and make it look some neat on art. But graphically, we can show the profits as a little rectangle. How much are profits? We already know the profits are $7. We've calculated it. That's maximized profits at 7. But we can also show it as a graph. Sometimes students get a little bit puzzled on this part. So before we do, let's just see if we can do average total cost. We should be able to do the average total cost because total cost or average total cost is this. That's the formula. Total cost divided by quantity. So we got our total cost. Total cost here would be 3 divided by 1, which is 3. 5 divided by 1, which is 5. 8 divided by 1 is 8. 12.
Hold on, wouldn't it be 4 and 3?
Yeah, what am I doing divided by 1 here? Dividing by 2, so that would be 4, you're right. Sorry. Divided by quantity. Yeah, so 12 divided by 3 would be 4. Right?
Yeah.
17 divided by 4 would be 4.25.
25.
Yeah. So I'll round it. 23 divided by 5, that would be 4.75. All right. 23 divided by 5. No, 6, right? You should be 4.6. Those little off, right? I don't have a calculator. I haven't done this. But I do want to make sure the numbers are right if we're going to try to plot it. What's that?
The first 0? 0, yeah. The first one is 0.
Oh, yeah, you're right.
3.
Okay, see, I'm making a mistake here. It's 0.
Yeah.
5 divided by 1 is 5. Maybe I should write it. 8 divided by 2. 12 divided by 3. 17 divided by 4. 23 divided by 5. 30 divided by 6. Well, that's 5. Okay, that should give us enough. All right? So that's average total cost. It's going to be one of those U-shaped curves. Okay? So when we plot that one, it's going to start out at average total costs are 0 at quantity, wait a minute, quantity is 0, average total costs are 3. So this is really going to, wait a minute. Total cost divided by, wait a minute.
5 at 1.
I'm looking over, I got so many things. See how I'm saying, if you got a big table, 5 divided by 1,
It's
8
5.
divided by 2,
4.
12 divided by 3, 17 divided by 4. Okay, all right. So let's not use 0. Let's not use that one. Let's use 1.
5.
At 1, we're going to have 5, so that'll be right about here. At 2 units, it'll be 4, about here. At 3 units, it'll be 4. At 4 units, it'll be 4.3. So we're going to go up a little bit. 5 units, it'll be
4.6.
4.6, it'll go up a little bit more. And 5 at 6 units, so about right here. This would be the closest we could get to our average total cost. I don't know how good this is going to turn out. The rectangle is what I'm looking for. I'm looking for something like this. So how you figure out what the profits are is the first thing you do is you find the marginal revenue, marginal cost, right here. Okay, we know that. We know that's right there. The quantity is somewhere between 4 and 5. I'll just say it's 4.5. I'm not even sure that's it. We're just kind of estimating there. It's 4.5, but like this example, that's your point C. That's where marginal cost and marginal revenue are intersecting. And so you take, what you do is to find the profit, to find this little rectangular area, is you come down to where it touches the average total cost curve. Just like with this, you come down to where it touches that average total cost. Here's your average total cost. And then you go straight over. You go straight over from there. So right over here we go. The problem is I don't know what this number is. I'd be guessing on it. It's somewhere between 5 and 4.6. No, 4.6 and 4.3. That's what it is. It's somewhere between 4.6 and 4.3. And let's just say it's 4.4. We'll just say that. Okay. So the rectangular area, like this one, that's shaded lightly, is between the price of the good of $6 and where it crossed that average total cost curve. That rectangular area is the profit, is the amount of profit. This area right here is the profit.